All right, today we're going to talk about solving quadratic equations using the quadratic formula, which I know most of you are used to and have done before. But I'm going to walk you through some examples, and then we're going to add a piece to it. So in your notes, you should have section 4.6 and today's date, October 3rd. And make sure you put quadratic formula as your heading, okay? If you need to, pause the video right now so that you can write this down. This was your quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, and it's all over 2a. Now the key to this is that our equation has to be in standard form. Ax squared plus bx plus c. So if it's not, you need to solve it so it gets into that form. And then you just use the same values. So in this example, a is 1, b is 5, and c is 6. 1, 5, 6 to plug into that formula. Okay? And that'll give you your two roots. When they're not factorable, this is the ideal time to use the quadratic formula. All right, so I'm going to do 3 examples with you here. The first one, and yes, I want these in your notes. The first one, we need to get this in standard form, so I'm going to subtract 35. So we have 3x squared plus 8x minus 35 equals 0. So I have a is 3, b is 8, c is negative 35. So in our equation, x equals negative b, so it'll be negative 8, plus or minus the square root of b squared, 64, minus 4, times 3, times negative 35, all over 2 times 3. So I have negative 8 plus or minus, that is divided by 6. So 64 minus 4 times 3 times negative 35 gives us 484. Now keep in mind you have 2 answers here because we still have that plus or minus in there. So I'm going to have negative 8 plus or minus the square root of 484, which is 22, all over 6. Okay, so if you need to break it up, you can extend the page here. Break it up separate, you end up with negative 8 plus 22 over 6, negative 8 plus 22, 14 over 6, which is 7/3. That's your first answer. Your second answer, negative 8 minus 22 over 6. So negative 30 over 6, which is negative 5. These are our zeros on our graph again. We have 2 of them. Okay? This one would have been factorable because they came out as a nice rational number, a fraction, and a whole number, or an integer, negative 5. Okay? So there's our first one. Next example. I need to get this in standard form. We need to get our ax squared plus bx plus c. I like a to be positive. It doesn't have to be. I just like it to be. So I'm going to subtract 12x from both sides. We're going to end up with negative 5 is equal to 2x squared minus 12x plus 13. I'm going to add 5. So I have 0 equals 2x squared minus 12x plus 8. One thing that I could do right here that'll make things easier on us is I could divide everything by 2. So I'm left with x squared minus 6x plus 4. Now, in my quadratic formula, oh, that's 13. Sorry, this is 18. So divide by 2, we've got 9. Okay, in my quadratic formula, A is 1, B is -6, and C is 9. So again, I have x equals negative b, so -6 plus or minus the square root of -6 squared. Remember, when you square that, you have to square the negative, so that'll be positive, minus 4 times a times c, all over 2a. So we have -6 is positive 6, plus or minus the square root. This is going to be 36 minus 36, all over 2. So x is going to equal 6 plus or minus the square root of 0, all over 2. The square root of 0 is just 0, so I'm going to always be adding and subtracting 0. So this particular one is just going to have one answer, 6 over 2. So x is going to be 3. And if you recall from everything we've done, this is where your vertex would land on the x-axis, okay? So we only have the one solution at 3. All right, one last example here. Again, on something like this, I like x squared to be positive. It does not have to be. It just makes it easier for me to see. So I'm going to add 2x squared to both sides. 0 is going to equal 2x squared minus 2x plus 3. So my a value is 2 from here. My b value is -2. And my c value is 3. In my formula, x equals -b, so -2 plus or minus the square root of b squared, which is -2 squared, minus 4 times a times c, all over 2 times a. So -2 is positive 2 plus or minus the square root. -2 squared is positive 4. -8 times 3 is -24, all over 4. So I end up with 2 plus or minus the square root of -20, all over 4. Now, this past couple days, we've been simplifying the square root of -20. You need to simplify that here, okay? So we're going to have 2 plus or minus the negative underneath, means we're going to have that I out in front. We have the square root of 20 over 4. Go back to your geometry days, simplifying the square root of 20 breaks down into 4 times 5, the square root of 4 is 2. So I'm going to have 2i square root of 5 all over 4. Yes, we can go one more step, because these are all divisible by 2. Every single part has to be divisible by 2 in order to simplify. So we're left with 1 plus or minus I, square roots of 5, sorry about the board there, all over 2. So in this case, we have 2 imaginary solutions, so it's not going to cross the x-axis, okay? It's either opening above it or below it. This particular one is a positive 2x squared when we started, so it's opening up. It's opening above it. Okay, so hopefully you remember the quadratic formula. The piece that is new is called the discriminant, and if you need to pause the video right here, do that, because I want you to have this down. The value of the discriminant. First of all, the discriminant itself is b squared minus 4ac. And that should be sounding familiar to you, because back here, go way back to the quadratic formula, look at where b squared minus 4ac is. It's under the radical. They're the same thing. The number under the radical is what we're talking about, okay? That gives us some clues as to what kind of solutions we're going to have. If it's greater than 0, if that number is positive, we're going to have 2 real solutions. That means it's going to cross the x-axis twice, okay? It's going to have 2 x-intercepts. If it's equal to 0, we're going to have 1 real solution. We talked about that. That means the vertex is landing on the x-axis. If it's less than 0 or negative, we're going to have 2 imaginary solutions, which means it's going to open above it or below it, and there's no x-intercepts. So let's go back to our 3 examples, which you should have in your notes. The first one, the discriminant, I can find that under the radical there, and that discriminant value was 484. So when we find the discriminant here in a minute, we're just going to find this value. This value is positive, so that means I had 2 solutions, and we came up with 2 solutions. Okay? Back here, my discriminant ended up being 0. So I ended up with 1 solution. And if you remember on our last example, my discriminant ended up being negative, so we had 2 imaginary solutions. Okay? So when we're trying to determine just what kind of solutions, we're not asking what the solutions are, just what kind of solutions we're going to have, we can look at the discriminant. So your directions are going to be find the discriminant of the equation and give the number and type of solutions that it will have. So in this standard form, our A is 2, our B is 4, and our C is -4. So you're just going to look at B squared minus 4AC, which would be 4 squared minus 4 times 2 times -4. Okay? Should be obvious to you that we get 16. Sorry, I'm going to come back over here to my board. 16. This is -8 times -4 is positive 32 is equal to 48. So we're going to have 2 real solutions in this case. And if you're asked what's the discriminant, is 48. Okay? All right, let's look at our second example there. The second example, you need to make sure you get it in that standard form first. So I'm going to bring it all over. I'm going to add 3x, and I'm going to subtract 3. So I get 4x squared plus 6x plus 9 equal to 0. A is 4, B is 6, C is 9. So again, in B squared minus 4AC, I have 6 squared minus 4 times 4 times 9. Okay? Now, we have a large negative number there. We end up with -108. Okay, so that's our discriminant. Negative meant we had 2 imaginary solutions. You might see them written as too complex. Same thing, right? Complex numbers and imaginary solutions are the same thing. All right, last example. I'm sure you know where it's headed, but let's practice it anyway. I'm going to bring everything over to the right-hand side so I can get my x squared positive. So it's going to be positive 5x squared minus 3x minus 1. 0 equals 5x squared minus 10x plus 5. This is one where they're all multiples of 5, so I'm going to divide everything by 5, make it easier. X squared minus 2x plus 1. So I'm going to have A is 1, B is -2, C is 1. So in B squared minus 4AC, I'm going to have -2 squared minus 4 times 1 times 1. So I'm going to have 4 minus 4, which is 0. So you're going to have 1 real solution. Okay? That's how you use the discriminant. Last type of examples. Again, pause the video here so that you can write this down. Here are our motion, kind of our launch type vertical motion problems. So If we do not have a velocity, h sub 0 stands for your initial height. In math, whenever you see a sub 0, it usually means starting or initial. Okay? So our initial height. This h would be our ending height. T is going to stand for time. That's if an object is dropped, so there's no velocity with it. If there's one launched, you're going to have a velocity. So it's going to be negative 16 t squared plus your velocity, your starting velocity, that's why it's v sub 0, your initial velocity, times t plus that initial height again. Okay? If your velocity is greater than 0, it's being launched up. If it's less than 0, it's being launched down. And if it is 0, it's parallel, okay? Or a straight drop kind of idea. All right, so let's go on to this one. A basketball player passes the ball to a teammate. The ball leaves the player's hand at 5 feet above the ground and has initial vertical velocity of 55 feet per second. The teammate catches the ball when it returns to a height of 5 feet. How long is the ball in the air? So in this case, we're looking for time, okay? We have a velocity here, so you want to go back and use this equation. So h equals negative 16 t squared plus my velocity times t plus my initial height. I'm going to leave this h alone for a minute. Negative 16 t squared. My velocity is 55. So plus 55 t plus, what's my initial height? It starts at 5 feet above. Sorry about my board there. Plus 5. Okay? We want to know, though, not when it hits the ground, but when it ends at 5, when it returns to 5 feet. So that's what this h over here is going to be. This h is going to be that 5. Okay? This one. So when you go into solving this, then you just want to solve for t. You can use any method we have at this point. So I'd want to subtract 5. Extend my page here. And I would get 0 is equal to negative 16 t squared plus 55 t. Now I can factor out a t. So I'd be left with negative 16 t squared plus 55 t. So my first answer is going to be t equals 0. My next one is going to be negative 16 t squared. Sorry, we shouldn't have a t here still, guys. That's gone. And this shouldn't be squared anymore. Guess I didn't really factor it out. Let's go back here. Plus 55. We just have, okay, when I took a t out of both of those, we get this. So now I go negative 16t plus 55 is equal to 0. Negative 16t is equal to negative 55. So t is equal to, when we're dealing with word problems here, change this to a decimal. So 3.44 seconds. Okay? All right, so that sums up quadratic formula, discriminant, and our application today. So what I need you to do is make sure you get your POW into the sub before you leave today. So make sure you get that from him. And then you can work on this homework assignment. There's 2 YouTubes here that I'll also post on Edmodo that you can go out. I know there's algebra teachers out there that sing the quadratic formula. I'm not going to sing it for you, but there's a couple of songs here. To Pop Goes the Weasel that you could, in case you want to have that. You have to have that memorized, so in case you need that to memorize it. So, see you Monday. Thanks.